Hi, in this video I'm going to show you how to simplify radical expressions that involve variables. And we're not going to be using our calculator. We're going to simplify these next few expressions by hand. So let's get started. The first thing I want you to do is I want you to take the expression underneath the radical symbol, and I want you to find the prime factorization of that expression. And what that means is I want you to take 75x squared y. I want you to write a factor tree. So I'm going to come over here to this side. Okay, I'm going to write that expression again. I'm going to start breaking it down. I'm going to first break down 75. So 3 times 25. 3 is a prime number, so I'm going to move it down. And then 25 is 5 times 5. Next, I'm going to go ahead and break down those variables. There's not many variables, but it's a good habit to just go ahead and rewrite them as x times y. Okay? This, what I'm kind of squaring in, that's the prime factorization of this expression because each of these numbers are prime. Next, because this is a square root, I want you to identify matching sets, like a pairs of two of the same number or two of the same variable. So if you look just inside this square, there are 2 5s and 2 x's. Okay? So here's how we're going to simplify this by hand. I want you to take the pairs, the numbers that you found were pairs, I want you to write those on the outside of the radical. So we had a 5 times x. Now I want you to draw back your radical symbol, and anything left over goes on the inside. So we had a 3 times y. And the last thing I want you to do, we really don't need those multiplication dots in there. So I just want you to rewrite this problem without those dots. It really can just be 5x square roots of 3y. And that's your answer for this first example. Take a look at number 2. We're going to go through the same process. I do want to point out that there is already a number on the outside of the radical, and that's okay. We will just, any extra number that we're going to pull out, we'll multiply it to that 2. First thing, I want you to go ahead and rewrite this expression and find the prime factorization. So 7 times 4 is 28. 4 times 4 is 2 times 2. And I suggest that you go ahead and just expand these exponents. So we have x times x times x, y times y times y. So this part, okay, that's the prime factorization for this expression. Because this is a square root problem, I want you to look inside that square and see if there's any pairs of matching numbers, any sets of 2 of the same number. And it looks like have 2 2s, 2 x's, and 2 y's. Okay? And we already had a 2 on the outside. So now we're going to, so here's my original 2. I'm now going to multiply it by the new 2 and the x and the y. Draw the radical symbol again, and each of these that did not have a pair stays under the radical, 7xy. And then the last thing you need to do just to simplify this, we really just need to multiply that 2 times 2. So you really should have an answer of 4xy square root of 7xy. And that would be your final answer for this example. In this next example, I'm going to show you how we can work through simplifying a radical. We can use the same steps even if it's a cubed root or a fourth root or a fifth root. So I want you to start off with in the same way. I want you to draw a factor tree of this expression underneath the cubed root. So 16a squared b cubed c. When you break apart 16, we can go ahead and do 4 times 4. And this is 2 times 2, and then 2 times 2. I do want you to get into the habit of just listing out these exponents with these variables. So you have a times a, b times b times b, and then you have 1c. So this is your prime factorization. Okay, now it's really important that you pay attention here, because after doing these problems for a while, something happens in our brain and we just start only circling sets of 2's, like only circling twins. But this is a cubed problem, and we know it's a cubed problem because of that little 3 on the outside of the radical. And when it's a cubed problem, you're now looking for sets of 3 of the same number. So you really have to pay attention and train your brain to really pay attention to what exactly you're looking for. So we are looking for triplets. We have 3 2's. I want you to circle. Only have 2 A's, so we cannot circle there. We do have 3 B's and only 1 C. Okay, so here's how we're going to formulate our answer. We're going to represent our sets of 3 on the outside of the radical by writing 2b. Okay. Next, I want you to write the cubed radical symbol back. It's really important that you put the cubed sign back in your answer. And we're going to just write what we have left over. There's 2 a's left over, so that's a squared. And then we have 1c. And so this is your final answer to this example. Okay, take a look at this last example. This is another example of simplifying a cubed root, but what do you notice that's different about this problem? Hopefully you notice that there's a negative sign underneath the radical. Now, usually if you're taking the square root of a number and that number is negative, well, that's impossible because we can't take a square root of a negative number, okay? However, you can take a cubed root of a negative number just because of the way the multiplication works. So for example, before we solve this problem, you know, if you had -2 cubed, okay, this would be -2 times -2 times -2. Well, a -2 times -2, this is a +4, but then when you multiply it by another -2, it's back to -8. And so because -2 cubed is a -8, we can then turn around and take the cubed root of -8, and that would equal -2. Okay, so if that concept is kind of new for you, you know, you may want to ask your teacher or do a little bit more studying, because we're going to use this concept right here to work through this last problem together. Okay, so let's begin on the last problem. It's a cubed root. I want you to do the same thing. Let me switch colors. I want you to rewrite the expression and then go ahead and make a factor tree. This is going to be 8 times 7, 4 times 2 times 7, and then we're going to break down this 4 to 2 times 2. And these other ones are already prime numbers. And even though it's kind of long, I do want you to go ahead and write out all 5 of those y's. Okay, and then don't forget that we do have a negative. So when we're working right here, Okay, we're gonna pull out that negative. We are looking for sets of 3. We have a set of 3 2s and then a set of 3 y's. Okay. When we pull out this set of 2's, we're going to attach the negative onto it because we're going to pull it to the outside. See, I'm going to run out of room here. We're going to write negative 2y because this represents our sets of 3. Put your cubed radical symbol. And we have a 7 left. We're going to put this in alphabetical order. An x and then a y squared. All right. So kind of got squished in there. Let me put a little circle around the answer. So this is your final answer to this problem. But now I want you to pause this video. Let's try some of these on your own and see how you do.